right, today, guys, do a little exponential functions. Before we get started, what we're going to do is we're going to write the basic concept for an exponential function. This is what you're used to seeing. All right? Y equals A times B to the power of x. Now, everybody, the A value is going to be what's called the initial value of what you're starting at. So, if you're dealing with money, you said you were going to deposit $1,000 into an account, that would be your A value in a word column. The B value, right here, is what's called either the growth or decay factor. The growth or decay factor. Now, what is it? No. You're right. Normally you're thinking positive or negative. But in exponential functions, the B value, if it's bigger than the number 1, that means it's getting bigger and bigger. It's growing. So if B is greater than 1, that's called growth. Right? It's a growth factor. However, if B is less than the number 1, but it's actually greater than the number known as 0, this is where things decay. Alright? So right now, any fraction between 0 and 1, things are going to be going down. So a growth function is going to look like this. It's going to be a graph that's going to go exponentially higher and higher and higher. So it's going to start out right here along the x-axis, okay? And it's just going to go up. Decay means you had a lot, now it's exponentially getting closer and closer and closer to 0. So it starts out with a lot, goes down really, really, really quickly. That's if you have a decay factor. We're going to talk about that. So let's just write now. What I'd like you to do is turn the graphic calculator on. We're going to investigate. Okay, sometimes it's easier to see and understand what's happening. So watch this. We're going to write 2 to the power of x. And I want you to hit the graph button. See how it goes up? Right here. Now, it looks like it's hitting the x-axis, but it really isn't. It's just really close to it, and it just rises, going up, 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 to infinity and beyond. But if I said y equals, watch, not a 2, but a 1.5, raised to the power of x, everything's going to get exponentially smaller, right? So it's going from here, going down, 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 close to 0, but never quite touching. Which one's the growth? The blue. Which one's the decay? The red. Alright? Alright, so now that we have both of those, what I'm going to do is I'm going to go down here, and I'm going to clear them out. And I want you to see a little bit of how to shift your graph. Alright? We're going to shift our graph left and right. I'm going to do 2 to the power of x. I'm going to say minus 1. And watch what happens when I graph this guy. Look closer right now. Do you see this point right here? This point is at a 0, 1. Where is this point at right here? 1, 1. See how I just shifted 1 unit to the right? Every point was just shifted 1 unit to the right. Check this out. What if I said 2 to the power of x minus 4? Oh, so it went from here, right, all the way to 1, 2, 3, 4, right there. Well, what if I wanted to make it go not to the right? I wanted to make it go left. I could. So this. So that's x minus 4. I'm going to say x plus 4. So, did you see that? Oh, plus 1. Oh, you did plus 1, so it went 1 over 1 to the left. You're like, wait a second. I don't get this. How is this one y equals 2 to the power of x, and then this one right here is y equals 2 to the power of x plus 4, but how did it go to the left? Because what number gets you back to where you started? A what? A negative 4, all right? So, by adding or subtracting, you're either sliding it what? Left or right? Well, what if I wanted to take this graph right here, and I wanted to take the same green graph, but I wanted it to go, I don't know, 4 units going down. Well, what I have to do today is make it go 4 units down and go through this point right here. I'd have to take this whole graph and do what with it? Take away what? Take away a 4. So watch what we're going to do. I'm going to go y equals. Go down to my green graph right here. X plus 4 bit. Watch. I'm going to go down here. I'm going to take away 4 from all of my y values. And watch what happens. There's the first one. There's the second one. Here's the. Hey, grab it. I dropped it down where? Right there. Let me go back to the previous. Right? Goes from here to where? Here to there. Here to there. Hopefully you can see the pattern. Okay? So, before we get off of this and move on to our next part, I'm going to try to take a screenshot of all of this. There we go. So, what does this part right here do? This shifts the graph 1 unit which direction? 1 unit right, correct? Now, this part, there's 2 things that happen. It shifts it 4 units to the left, and then it goes 4 units down. Okay, so I want you to understand how the exponential graphs work. So what I want you guys to do on your first few problems is just graph them. Okay? Now, we're going to zoom in on number 1 real quick. The number 2, right there, that's your b value. So if your b value is 2, is that growth or decay? The b value is 2, which is greater than 1. That would be growth. Okay, so we're going to go tricky one. What makes this one a little bit tricky? What does it look like your b value is? But it's not. Let me show you why. Write down number 2 in your journal. I'll show you why the b value really isn't the number 4. Check this out. If I have y equals a times b to the power of x, all right? And my equation is y equals 4 raised to the power of negative x plus 2. Is this equation right here, does this equation deal with a positive x or a negative x? Deals with a positive. So we got to make sure, we got to change this x to positive. So watch that. Watch how we do this. I'm going to take this 4 right here, and I'm going to factor out a negative 1 out of this expression right here. If I factor out a negative 1, what's going to go right here? An x, because negative 1 times x is a negative x, right? Negative 1 times x is negative x. Negative 1 times what number gets me a positive 2? Negative 1 times what number gets me a positive 2? Negative 2. Now, I want you to really focus in on 4 to the negative 1. 4 to the negative 1 is the same as 1 over 4. Just remember, when you're dealing with exponents, b to the negative power of n is 1 over b to the power of n. So I want you to understand, negative exponents are dealing with fractions right there. So what is our actual b value? Our actual b value is 1 over 4. What is 1 over 4 raised to? The power of x minus 2. What I'm going to do is I'm going to prove to you guys in the graphic calculator that this equation right here is actually, everybody, actually equal to this equation. What is our b value? Our b value is actually what? 1 over 4. And 1 over 4 is considered to be a decaying function. It's not a growth, it's definitely decay. So here we go. I'm going to pause. All right, problem number 2, our original function was 4 raised to the power of negative x plus 2. Okay, graph. Look what happens. So everybody see how it gets to the decay function? It goes down, right? Okay. Now, what did we say it was actually equal to? I said it was a by 4 raised to the power of what? X minus 2. If these are exactly the same, what should happen in my graphing calculator? What should happen? One should trace over the other. That lets me know that this is indeed the correct function. There's other ways to write it, okay? So understand, problem number 2 is what type of function? Problem number 2 is a decay function. Problem number 1 is a growth function. I want you guys to use your graphing calculators. Here's how you graph it. You hit second table, and you look for points you can actually plot. Can you plot a 1, 4? Yes. Can you plot a 2, 1? Yes. Can you plot a 3 1/4? Yeah, you can estimate those. All right? So plot the points that you can actually plot and just graph them. So do your best. Make this graph right there on your paper. That's what you're doing for the first 4 problems, is your graph. All right, we're going to do one of these together real quick. I'm going to go y equals. I'm going to clear these out. All right, and I'm going to type in one of our problems, which is negative 3 raised to the power of x. Oops, plus 1. And I'm going to hit graph. And you see this. This is what we're going to plot on our paper. So I'm going to zoom in. Problem number 3. Here we go. Problem number 3. Now, I'm just going to start with, I don't know, negative 3, negative 2, negative 1, 0, 1, and 2. So I'm going to look at my table. That's the first thing to do. Check my table. Second graph. Ooh, negative 3 is 0.963. So we'll take a snapshot of this. I can go back and forth. 0.963. So basically, 0.96, what's that really close to? The number 1. Very good. Negative 3, really close to a 1. I mean, we're talking really close. Then we're going to go negative 2, what? 0.9. Another point, really close to 1. Keep going. 2/3. That's what 0.6 repeating is. So negative 1 2/3 is about right there. Then we have 0, 0. That's pretty easy. That's the easiest point to plot right there. 0, 0 right there on the origin. And then we have 1, negative 2, and 2, negative 8. So we have 1, negative 2, and 2, negative 8. So we have 3, 4, 5, 6, 7, 8. Now this is greater than. There's 2 things that are happening. Number 1, you're going to connect these dots not with a solid curve, but a dotted curve. All right? And number 2, if that says greater than, that means you're going to shade above that dotted curve. Shade above. So the first thing I'm going to do is I'm going to make a nice dotted curve. Now understand, it is not going to get past this positive 1 right here. There we go. So we have a line curving going through that. No, it's not a line. It's a curve going through all those points. And then we're going to shade everywhere above. So we're going to shade everything right here above that dotted curve that we did. And right there, everybody, that is a reasonably accurate graph or depiction of this particular exponential inequality. All right? So how do we do this in the graphing calculator? Here's how you can do it. You can go to y equals. You can go over here to the left, and as long as you know that we're shading above, you can change this to shading above. That's shading above. That's below. Above. Below. Above. Below. Go down to OK. Hit enter. Hit graph. Now, the only thing that this particular mode does not do is it does not give you that dotted line. So you would have to know to do the dotted line. Now, there is an inequality app that you could use. All right? So if I use apps and I go to inequality, number 5, it equals, press enter. Then what I can do is I'm going to go back over here. I'm going to change this to not equals, but oh, look at that, greater than. See, it has dotted. All right. Change the style here. Go greater than. Right here, y is greater, dotted shade above. Go down here. Click OK. All right. And graph. There we go. So there's the dotted and shaded above. But you have to have the app called this n equals, which it says, I'm going to go and quit it now, the inequality graphing app. So you have to have that in order to do it. So that right there is problem number 3. Now we need to move on to problem number 8. Number 8? Yes, we're going to do problem number 8. Right now, for number 8 in your journal. This is the last problem we're doing. Hopefully we'll have this video will be less than 20 minutes. It's getting a little old right now. So right now, write down problem number 8 in your journal. And write. Hopefully, Caitlin, you're watching this because you were not here at school today. You're sorely missed. So hopefully, you'll watch this and get caught back up. There we go. Y equals A times B to the power of X. Whenever you plug in a 0 or X, this will always be your A value. This is your value for X, and this is your value for Y. You'll notice magically colors just appeared on the screen. All right. You'll notice that my A value is -5. My X value is -3. And my Y value is -135. Adam, I bet you can never tell me what I'm going to plug in for Y. Brilliant equals. Angela, can you tell me what I'm going to plug in for my A? Oh my gosh, you are magical. All right, we're going to put right here. I'm going to put B in a totally different color. And together, what am I going to plug in for X? -3 is I don't know how you guys are able to figure that out, but that was really. Now that we have everything plugged in nice and neat, what we're going to do, everybody, is we're going to solve for B. Now, here's the steps to solve for B. So in case you need to rewind this and watch it, you can. The very first thing that you're going to do is you always divide both sides by whatever you had for A. So our A value was a -5, so I divide both sides by -5. Now if you want to multiply both sides by the reciprocal, that will still work. And the reciprocal of a -5 is -1/5. So if you multiply both sides by the reciprocal, it would still be the exact same process. So dividing by -5 or multiplying both sides by -1/5 will still work. Boom. Those cancel out. -135 divided by -5. Which is equal to B to the power of -3. Now everybody, not every single person in this world knows what number raised to the power of -3 is a 27. So we do have a graphing calculator, which you can use. If you choose to use a graphing calculator, here's what you got to do. You got to multiply this exponent by the reciprocal. And the reciprocal of a -3 over 1 is a -1 over 3. Whatever you do to one side, you must do to the other side. So these cancel to just B to the first power. And B to the first power is just B. And then you're wondering probably, what is 27 raised to the power of -1/3? Well, you can type that in the graphic calculator and get an answer. Or you can change the number 27 to 3 to the power of 3. Because 3 times 3 times 3 is 27. Raised to the power of -what? -1/3. This is called a power of a power, which means you're allowed to do what? You're allowed to multiply them together, and you get 3 to the -1 equals B. Last thing. Here we go. 3 to the -1, everybody, is 1 over 3. So what is our B value actually equal to? 1/3. Is this a growth or a decay factor? Decay. We did all of this to solve for what letter? We did all of this to solve for B. So here's our final answer. Your final answer for this problem is Y equals, you always plug in your A value, that's your initial value, which is a -5. I'm opening up a parentheses. What did we find B to be? 1/3. Raised to the power of X. That is your final exponential function that goes through this point and goes to this point. Well, how can I check this answer if I have a graphing calculator? Well, here's how you do it. You go to y equals. I'm going to clear this guy out. How am I going to do? -5. Open parentheses. 1 divided by 3. Close parentheses. Raised to the power of x. And we're going to check our table. And yes, we are able to prove that -3, -135, and a 0, -5 are what? Are 2 points that go through our equation. And that's your final answer for number 8. That's the process you're going to do for all the other ones. Okay? Plug it in, plug all the values in, solve for b, then rewrite the equation. Have a wonderful day.